This is answer 2021, section 1, question 60. So, we are told that in an experiment, a spoonful of magnesium carbonate powder is added to excess hydrochloric acid in an open conical flask. The mass of that flask was measured at different 1 minute intervals up to 5 minutes, and our reaction is given here. And we're asked which row could represent the total mass of the gas calculated each minute. So we have some different calculations of the gas that was produced. So where is a good place to start with this question? We don't really know or can link these numbers to anything yet. So what I would suggest doing is drawing a little graph of what's going to happen in this reaction. So this is a little diagram of what's happening in our experiment. We have an open conical flask, and as things react, we're losing this gas, and this lost gas is what is being measured. So let's try and draw a little graph. We know that our gas, which is being lost, the mass of our gas, is going to be equal to the rate of our reaction, because the rate of our reaction is indicating how much gas is going to be produced, and therefore how much of it is in mass. So what does our reaction rate look like over time? We know that things are just going to keep reacting, but is there anything that's going to be limiting in this reaction? Is there anything going to slow it down or speed it up? We know we only have a spoonful of magnesium, but we have excess hydrochloric acid. So we're going to have a limiting factor of the magnesium carbonate. Therefore, as we use up our magnesium carbonate, our rate is going to decrease. And so our rate of gas production is also going to decrease. So we've got lots of magnesium here, reacting very nicely, but as we lessen that concentration, our reaction rate is going to go down. So we're looking for a decrease in the rate of gas production. So let's compare that to our table. So back at our table, how can we tell what the rate of gas production is doing based on our rows in our table? Well, to find the rate, we have to find the difference between our values. So, for example, for this first one, A, we see it goes from 4 units of gas to 3 units of gas to 2 to 1. And so our rate is decreasing, the rate of gas production is decreasing. And if we do that for the rest of them, we can see for B, it goes to 3, 4, 5, so it increases. For C, it just stays constant at 3. For D, it stays constant at 1, and for E, it goes for 3 to 0, so our rate decreases. And we know from our graph that we're looking for a decrease in rate, so we can cross out these 3 in the middle. So we have 2 possible rows it could be our A or it could be our E. What is the difference between these two things? Well, it differs in when our reaction stops. We know in the question that our reaction is stopped at 5 minutes, but if we look down here, no more gas is produced after the 4th minute for E. The reaction is stopped at 4 minutes. Therefore, it cannot be this one. It must be A. So our final answer overall is A.